So in this video, we're going to look at ketones and aldehydes specifically. How to name them, how to make them, reactions we can do with them. And we've seen a little bit of that already, right? Especially back in the Grignard reactions and when we oxidize alcohols into ketones or aldehydes, but now we're going to be looking at some of these. And in particular, the next few chapters, really the rest of the semester, we're going to be looking at carbonyls in various different ways. So with aldehydes and ketones, we're going to talk about how to name them. So again, kind of like usual, adding a few more names to our naming list. So we're going to start off with aldehydes first. Aldehydes in general take higher priority than ketones naming, mostly due to the fact that aldehydes, right, are kind of at the end of carbon chains because of the hydrogen at the end there. So the longest chain must contain the aldehyde or the ketone. So no matter how we're naming it, we need to make sure the aldehyde or the ketone is taking the higher priority, right, or the lower number. Right, and now, so for aldehydes specifically, right, aldehydes are always going to be carbon 1 in a chain, and when we're naming them, we're changing the end of the name from E to all, okay? And this is kind of a wackier naming rule here, but if we have a carbonyl in a ring, we need to add carbaldehyde to the suffix, okay? So let's take a look at some of these things in terms of putting them to use. So we have a few examples here. So for the first one, pretty easy, right? We have an aldehyde as a part of a carbon chain here. It's a really short one. And so while normally, right, a 2-carbon chain would be ethane, we would call this ethanol, just like this. It's kind of the same situation where you could put one all, but it's kind of assumed, again, like we said before, that the aldehyde is the first carbon of the chain, right? So have ethanol is like this, it's totally fine. So the second example here, kind of ignoring stereochemistry on that 4th carbon with the bromine, where we have bromine in that 4 position. So the full name for this would be 4-bromohexanol, okay? Our next example here, again, we have an aldehyde and a ketone, right? It's 2 examples here of 2 different functional groups, but we want aldehyde to take priority. So we have 1, 2, 3, 4, and when we get to this 4th position, where don't forget with alkenes, we have to have both carbons part of the chain. Even though, right, labeling this the other way would make a longer chain, that gets kind of complicated, so we kind of reduce complication by having the alkene part of the carbon chain. So the name for this would be as follows: 4-ethyl pent-4-enal, right, with that 4 there, denoting that's the alkene, right? There's no stereochemistry, so we don't have to worry about E or Z. So this next example here, again, sort of not a exception to the rule, but one way we can name this is calling it benzaldehyde. So this is not an example I would give you on a test or anything. This is just an example of a different way we can name things. But if we had to give this the full name, like IUPAC style, this would actually be benzene carbaldehyde. Again, aldehyde part of a ring. Okay. So for this final example here, we have this cycloalkane, and so, right, we want to make sure our aldehyde is in our 1 position. So we would number it like this: 1, 2, 3, 4, 5. Okay. And then the full name for this would be 2-methyl cyclopentane carbaldehyde. This carbaldehyde is kind of, right, it's important at the end because it's not really a great way to denote whether or not we have an aldehyde in the ring. So we have to say carbaldehyde at the end there. That's implying, right, we have that aldehyde in that 1 position, okay? It's sort of a again, a weird example of naming, but this is sort of how the pieces fall, right? All right, so now thinking about ketones here, right? We have an example of some different ketones, and the rules for these are, maybe expected at this point. For ketones, we want the longest chain to contain the carbon of the carbonyl. And the suffix we change from E to -one, right? And so we want to number the ketone. So the ketone is the lowest number possible if no aldehyde is present. Right, because aldehyde takes priority over ketones and naming, right? Again, naming is one of these things that, there's a bunch of rules, right, but they're not really scientific in any way, so it's kind of a lot of weird nomenclature memorization, right? So with our first example here, right, a simple one, we have propane, right, this propane chain with a carbonyl in the middle of it. So the way we would name this is propane 2-one, right? The 2 again just indicating where the ketone is in the chain, even though it could really only be in the 2 position, right? Because if it was 1 or 3, it would actually just be a aldehyde, right? So the next one here, when we're numbering this, we want to number from the ketone, right, taking priority even over the alkene. And for the name for this, right, we've numbered it like so. We have in the 4 position that methyl group. And then we have, right, hexane, right, is the chain, but we have an alkene and an -one. So we need to denote them properly in our naming. So 4-ene 2-one. Right? So this is the name for this molecule. And actually this alkene does have stereochemistry, just to add more complication, right? So that is actually, no, that is not right. E, right? That is the E alkene. All right, so for our last example here, we have a ketone, but now it's in a ring. And so we want to number it like so. So the ketone, right, is in our 1 position, and we want to, again, get the lowest number possible across the ring. So we want to go clockwise towards the alkene. 3, 4, 5, 6. And so the name for this is 5-methyl cyclohex 2-ene 1-one. We don't have to say 1-one. You could say 2-ene-one. It's implied that the ketone is in the number 1 position. And because the ketone can be part of the ring, right, because remember in that last example we had, right, if we wanted to get an aldehyde on a ring like this, we wouldn't be able to, right, because the aldehyde has to have a hydrogen present. So we have to, that's a terrible drawing, sorry. So we have to have the aldehyde off the chain like this. Hence that carbaldehyde naming scheme we need to follow. But with ketone, we don't need to do that. Ketones can be part of the ring, no problem. Okay, so those are the basic rules, and we'll get some practice doing these in class. One last thing I wanted to touch on is, like I mentioned kind of at the beginning of the video, we have a list of reactions we've already seen with aldehydes and ketones. So take a look back at some of these previous reactions, right? The oxidation of alcohols, right, with PCC, ozonolysis, right? We saw these reactions where we break apart alkenes, right, to make ketones and aldehydes. Friedel-Crafts acylation, right, adding on those carbonyls to aromatic groups, and these Grignard reactions, right, where we can attach things to things like esters and acid chlorides. Right, these are all reactions we've already learned, so we'll kind of leave it up to you to review these, and we'll touch on these in class too to get ourselves ready for the rest of the chapter, where we're going to look at new ways to look at making aldehydes and ketones and potentially reacting them.